All right. Let's see. Do we have sound? Yeah, looks like we have sound from the microphone to OBS. Let me get my Twitch page open so we can load the chat there. In case we have any visitors. Just a heads up. Very loud. Just a heads up. I don't have the video turned on today, so this is going to be screen share only. I didn't set up the camera. I'm kind of feeling not quite under the weather, but my allergies, I guess, have been giving me some trouble the last couple of days. So I didn't really feel like getting the camera all set up and doing that, but I did want to stream and work on this, so I figured a good compromise would be to just throw the screen share up only for now. There we go. Okay. Some of that stuff set up over there. Okay. So, unrelated but interesting / exciting. Congratulations, of course, to NASA and everybody working on the DART project. As of about half an hour to an hour ago, they successfully crashed I guess some sort of little satellite or something. I'm not entirely sure what it was, but they intentionally crashed it into a particular asteroid to A, get practice actually hitting something like that, and B, to measure the effects of how much we change its trajectory by running that thing into it. And so just a few minutes ago this evening, they did successfully hit that asteroid with their craft, and that was streamed live. So if space or that kind of thing is interesting to you and you didn't catch that, I would recommend go try to find the video. I'm sure there will be videos out there on YouTube already. It was being streamed by NASA on YouTube, so I was watching that live, and that was quite a fascinating experience to watch something like that. But jumping into our actual content for the night, I am working on JavaScript, and specifically I'm working on the exercise that is in chapter 16 of this book, Eloquent JavaScript. This book is freely available online, I should say. Anybody is allowed to access this website and read through the entire book. This is the entire book right here. All 21 chapters are on these pages. You can click into them and see the entire chapter of each one of them. So this is freely available online. You don't have to pay for web access. There is a hard copy of this book. You can buy a physical copy, and of course you have to pay for that. But the web version is completely free. It's a pretty good book for learning JavaScript. And I would say it's a decent book for learning programming. It's a little bit in depth. It's a little bit maybe over the level that you'd really want as a first-time programmer. But it takes some time in the first couple of chapters to explain the fundamentals. So if you are trying to learn how to program, it can be used for that, but I find it's mostly best for people who have at least a little bit of programming experience, but are trying to learn JavaScript for the first time. So I'm going to be working on chapter 16 from here, a platform game, and I'm just going to jump straight into that. So I'll be going back and forth between the book and my IDE here. To start with, I am just going to take a copy of the web seed and put this into advanced examples. We'll call this chapter 13. Is it 13? No, 16. 16? Yeah, 16. Platform game. So that web seed right there just has an index.html, a script.js, and a style.css. They're already all linked together. But it doesn't have anything else. There's no other content in it. It's kind of like the bare bones, most boilerplate thing you need for a web project. So let's see here. Oh, and I would encourage folks, if you want to work along with me during this, like, feel free to pull up this page, work along on your side. You can, if you're watching this VOD in the future, you can, of course, pause and resume as needed if you want to work along at the same pace as me. If you're just interested in watching along, that's cool as well, but this will be the thing I'm building. Here's an example of it. It's a platformer game, a very basic platformer game, obviously, like just made with blocks, and then the player can run around. The player, I would presume, has to try to avoid the lava and collect the coins. And then there's ways you can build the levels for this as well. So that's the project we're creating. I'll read this first intro bit a little bit. Let's see. I'm gonna zoom. Yeah, that's much better. Yeah. I don't have any experience in the gaming industry, but I kind of get the sense this is the case, certainly. I don't know that I would go so far as to say, I don't know as though I would go so far as to say this, right? Like, if you want a career in the game industry, like, go for it. I say that's awesome. I think there's most likely plenty of people who are very happy with their career in the game industry, but so I wouldn't necessarily say this, but I do assume that what they go on to say here is probably a very true thing, which is that lots of people want to be game programmers. Lots of people who are willing to put in a lot of time and a lot of effort to be a game programmer. And that means that sometimes in that industry, maybe the pay is not the greatest, or maybe the experience is not the greatest. Like, you may be overworked, you may be working like super long hours, very difficult projects. There's always somebody who's willing, ready, and wants to take your spot. So the game companies certainly don't need to treat developers super well because they're quite replaceable. I'm sure that's not the same across the spectrum. I'm sure not every gaming company is like that, but that is a sense that I have gotten to an extent, is so many people are willing to do that work, so many people want to do that work, that they can always find somebody new, so they can always just work you as hard as you'll work, and then whenever you've had enough, the next person's right behind you. And I would also agree with the last part of this. Writing games for fun is amusing and fun. I've definitely created a couple of different games, nothing super major. I've released some on Android. I've released some just open source online. I have not ever sold a game or tried to profit directly from a game, so I wouldn't say that it's my industry, but I do have fun creating them, and I do think it would be a fun type of thing to work on day in and day out. Dark blue. I'm not familiar with this. Not mobile friendly. Press the up arrow key to start. Okay, yeah, I can definitely see the similarity. Yeah, okay. Darkbox is the player whose task it is to collect the coins while avoiding lava. Levels completed when all the coins have been collected. Player can walk around left and right arrows. They can jump with the up arrow. One thing I want to do is allow WASD instead of arrows. The arrows on my keyboard, at least, are split between two different hands, which was one of the things that took quite a lot of time to get used to, but I am more or less used to it at this point. Up and down are on my right hands, index and middle finger, which I am holding up in front of me as though you can see, but obviously you can't. Sorry about that. Right and left arrow keys are on my left hand, index and middle finger. And so it's kind of difficult to use them as a D-pad to play a game, but WASD is perfectly aligned as a D-pad, so we could maybe add that as an extra option. Static background, it's laid out like a grid. Moving elements are overlaid. Each field on the grid is either empty, solid, or lava. Or coins? Is coins solid? I don't know. The moving elements are the player, the coins, and certain pieces of lava. Interesting that the coins move. Maybe, I don't know if they mean like scroll as the player moves along the level, or if they mean that the coins actually do change positions. Positions of these elements is not constrained to the grid. Their coordinates may be fractional, allowing smooth motion. We will use the browser DOM to display the game. Handle key events to move around. Screen and keyboard related code is only a small part of the work we need to do to build the game. Since everything looks like colored boxes, drawing is uncomplicated. One of the things we may do, I don't know exactly how long it's going to take to do this, so I don't know if I'm going to do the whole thing tonight or what, but I plan to work on it at least for a little bit here tonight until I'm feeling like doing something else, basically. One thing that might be fun, though, is to give it an extra pass implementing some more fancy graphics. Maybe we could get an actual little player sprite and an actual coin sprite. Lava would be trickier, but maybe we could find something. Might be kind of fun. Represent the background as a table, since it's an unchanging grid of squares. Free moving elements can be overlaid using absolutely positioned elements. In games and other programs that should animate graphics and respond to user input without noticeable delay, efficiency is important. Although the DOM was not originally designed for high-performance graphics, it's actually better at this than you'd expect. Saw some animations back in Chapter 14. On a modern machine, a simple game like this performs well, even if we don't worry about optimization very much. The next chapter will look at another technology canvas, which provides a more traditional way to do the graphics levels. We'll want human-readable, human-editable ways to specify levels. It's okay for everything to start out on a grid. We could just use big strings, which each character represents an element, either part of the background, the grid, or a moving element. Plan for a small level might look like this. So I suppose @ would be the player, hashtag would be the walls and floors, probably the O's would be a coin, and then I guess equals maybe would be lava, or the periods are empty space, hashtag walls, plus signs are lava. Okay, so there's lava down here on this one. Every O character is a coin. The equal sign at the top is a block of lava that moves back and forth horizontally. Okay, that lava block does move. Support 2 additional kinds of moving lava. The pipe character creates vertically moving blobs, and the V indicates dripping lava. Is vertically moving, it doesn't bounce back and forth, and it only moves down, coming back to its start position when it hits the floor. It'd be like a steady drip of lava. Full game consists of multiple levels. The player must complete a level is completed when all the coins have been collected. Player touches lava, the current level is restored to its starting position. The player may try again. Reading level. The following class stores a level object. Its argument should be the string that defines the level. So I am going to be coding this stuff in, and of course I could just copy paste this, but part of the purpose of this is to get the experience of actually putting it in and finding what things are problematic, what parts trip me up, what parts need extra attention, what parts have gotchas. That is kind of the goal of what we're trying to do here. So instead of copy pasting, I am going to go ahead and actually type this stuff in. So we've got a level class. Constructor takes a plan. Trim. So I think trim would be removing extra spaces, white spaces, maybe at the beginning and end. Split on the new lines. Map is basically gonna assign a function to get called for every item in the list. So ultimately, this is going to give us back a list of each row inside of our level plan like this. And then map, we want to call a function on that particular row. They declare this function this way, which is not probably how I would write this. What is this? So we have arrow notation function. It accepts a single argument, and then it returns a list of... What does this do? We're going to do a little bit of experimentation. I don't personally use arrow notation functions too much. There's like one specific case where variable scope is affected differently for arrow notations as opposed to like function declarations. That's pretty much the only time that I use arrow notation, is if I'm in that situation where I really want the different functionality. What are we missing? Statement? Oh, this doesn't want to be here. Does want to be here. Doesn't want the one below. So I'm just going to print this. So I'm not actually sure what this is going to be doing. Let's also go maybe mdn ... Is that going to get us somewhere? Is that going to be... Yeah. It's tough. Operator, I guess? Not on this page. Ah, no. Oh, that's not what we want. Spread syntax. Allows an iteratable, such as an array or string, to be expanded in places where 0 or more arguments for function calls or elements are expected. In object literal, the spread syntax enumerates the property of the object, adds key value pairs. Spread syntax looks exactly like the rest syntax? Like rest syntax? I don't know what rest syntax is. In a way, spread syntax is the opposite of rest syntax. They should probably look differently then. Spread syntax expands an array to its elements, while rest syntax collects multiple elements and condenses them. Okay. Okay, so it's going to... It's basically going to fill in all of the items inside this list as though they were inside of here. Right? This ... numbers, this is basically going to convert to this. Because it's going to get each of these things and spread them into the individual elements. Yeah. Okay. So L is a list. And all we're doing is just returning a list of all the items in L? How is that different than just returning L? Huh. Oops. Let's look up map. Get a refresher on map. It's vaguely speaking, it I believe iterates over a list and calls a function on each thing in the list. Creates a new array populated with the results of calling a provided function on every element in the calling array. So we're kind of like rebuilding this list of rows inside the map. Let's read what they say about it. Trim method is used to remove white space at the start and end of the planned string. Allows our example plan to start with a new line so that all the lines are directly below each other. Remaining string is split on new line characters, and each line is spread into an array, producing arrays of characters. Okay, that does make sense, of course. Each row... okay, so I was calling this a list earlier, and its variable name is L, which kind of implies list. Really what it is, though, is it's a row string. It's one of the rows inside of our map. And then we're spreading its contents into a list. So we're converting a string into a list containing each of its characters. Okay. Whoops. I do want to try to run it if we can, but I don't know if we're going to be able to. Oh, we shouldn't call that map. So trim will get rid of this new line, basically. Yeah, trim will get rid of this new line, which we could do this and it would work the same, but now this row is not stacked on top of these ones. So they put the new line and then use trim to get rid of it. That way these can actually be vertically aligned here. Whew, that is very bright. Okay, we've got an array. Which, in the 0th element, in the first element of the array, has another array which has 206 things in it. Each one of these is one of the characters. Interestingly, we do still have our new lines inside, but we can see that we don't start on a new line. So it did trim that one off. I guess trim only does beginning? Perhaps beginning and end? Start and end, yep. Okay, so let's get the rest of this one put in. Height property equals the number of rows. Width property equals the length of the first row. So this is assuming that all of the rows have the same length. That's a good thing to note. Empty list of actors. I wish this was letting me be a little smaller here. And it gets run off the edge. Okay, so one thing that's a little odd is this is a local variable inside of here called rows, but then we are also making a rows property on the object, which are two different things, but both have the name rows. Probably would be good to make one of them different. Okay, so in this time we're getting a function with two arguments, the row and the y. And I'm actually gonna do declaration notation just because I find it easier to read and understand. Although we are nested in here, aren't we? CH would be character, I guess. So we're going 2 levels deep here, I guess because we're going to be mapping rows and columns maybe. So rows property is going to be equal to our list of characters mapped with this function that accepts the row and the y. We're creating another new list. And this one's going to be a list of lists because map is going to give us back a list of the things that we return from here, and it looks like the things we're returning from here is another map, which means we're going to end up with a list of lists. We don't have level chars. To see where that ends up coming from. I also don't care for if statements that don't have brackets, so I'm going to use brackets here. Makes my code longer, but I think it makes it easier to read and understand. So one downside of changing over to use the brackets and also of using declaration notation, we're not quite mapping up exact. We have to figure out what we did wrong here. Statement expected. So I think we don't want this, right? Yeah. Yeah, see, this one, it's weird. It's called rows, but what we saw is it's actually not really rows. It is one big list of every character. Maybe that was supposed to be this. Read into an array, producing... Oh, this does say arrays of characters. Oh. Okay. Yeah, that will definitely change what's going on here. Don't get any prints. I guess because I commented this bit out. Char's not defined. Okay, that is more like what I expected the first time, and makes a lot more sense why it would be called rows. We have a list of lists. Each one contains all the characters from that row inside the map string. I guess this must just be an array or an object that we have not declared yet. Okay, so rows holds a... I like the term list. It's just easier to say and quicker, and it's the term that comes to mind for me, so I'm going to say list. Rows holds a list of lists of characters. The rows of the plan, which plan is what they're calling the map string, can derive a level's width and height from these, but we must still separate the moving elements from the background grid. We'll call moving elements actors. They'll be stored in a list of objects. The background will be a list of lists of strings holding field types such as empty, wall, or lava. Create these arrays, we map over the rows and then over their contents. Remember that map passes the array index as the second argument to the mapping function, which tells us the x and y coordinates of a given character. Okay, so this outer map is looping over the rows. Each time it's getting past the string that represents that row as well as the index of that row. 0, 1, 2, 3, whatever. So then inside of here, we're mapping over each character within the row. And then we get the index here. So the current index of the current row we're on is our Y position, and the index of the current X that we're on, or the within the the character within the row, the index of that character, that is our X position. So then type is going to look up from this, which I assume will be an object that we create with key values, mapping the symbols that represent the different types. In fact, I mean, let's go ahead and do that? I mean, I'm sure they'll have us put this in, but so dot was empty. Hashtag is wall. Wall? Yeah, wall. Wall. And lava, which was plus. So now this dot rows is actually going to be holding another list of lists, but this time each of those sub items inside those inner lists are going to be the actual strings that represent each type of block. I'm just going to verify that it's actually doing what I'm expecting. This is undefined. Ah, we have gotten ourselves here, haven't we? So I just mentioned a few minutes ago about arrow functions, and I don't normally use them, but there is a specific situation where they behave differently with regards to scope, and we are actually in that situation. Okay. Yeah. So the problem is we can't access this inside of here. Inside of here, this is referring to, I guess, undefined, or maybe this function or something. It's not referring to what we want, which is this object here. The reason why it's not is because of our scopes. So I got ahead of myself. We actually do have to use arrow notation here, I'm pretty sure, because this is going to allow those variables in the outer scope to be visible to this inner scope. Specifically, it's going to let this, which is the special variable inside of here, representing the instance of the object. I'm thinking with declaration notation like we had, it's not giving us access to that. Type is undefined. So we actually have the same... No. We did arrow notation up here. I mean, I guess one thing is we would get to here and this would crash. So do we have... We don't have any other functions? So we're all arrow notation at this point. It certainly seems like we're still not being able to access type though, right? Type is undefined. Okay, type, okay, these aren't going to be strings. These shouldn't be strings. These need to be something that has a create function. Yeah, this needs to be something with a create function. We did get ahead of ourselves here. I don't know why they don't. I wish they would have put this up front, truthfully. Oh, okay, it could be either, I guess. If it's a string, then just return it. Else, if it's not a string, then it's got to be some kind of object that has a create function. I don't know, why was it saying type is undefined, though? Wouldn't it be that type is a string and therefore doesn't have create? Type wouldn't be. Type should be defined. Or no, okay, type is undefined because we have some that are not in here yet. We don't have these or @ signs yet, so... Okay, it gets undefined because it tries to access property that doesn't exist. Okay, that makes sense. Positions in the game will be stored as pairs of coordinates, with the top left being 0, 0, each background square being 1 unit high and wide. Interpret the characters in the plan. Level constructor uses level chars, which maps background elements to strings and actor classes. Actor character classes. When type is an actor class, its static create method is used to create an object, which is added to start actors. And the mapping function returns empty for this background square. When type is an actor class, its static create method is used to create an object, which is added to start actors. And the mapping function returns empty for this background square. Okay, so if it was a class, if type was a class, we call create, we add that into here, and then we return empty. Okay. Interesting. So I guess, I mean, that makes me think that we won't actually have these things in here. Right? Maybe we're not actually missing these. Maybe these need to be handled some different way. As the game runs, actors will end up in different places or even disappear entirely. As coins do when collected, we'll use a state class to track the state of the running game. This is pretty much just an object that holds a couple variables for us. Curious why actors says it's not used, or whatever, compared to the other two. I am not familiar with this get function. I don't know that I've used that before. So get players is going to loop over all the actors, call this function for each one of them. Function is going to get past the current value. It's going to check the type on it, and if it's equal to player, then it's going to return true. If not, then it's going to return false. This will cry because of type coercion. We will leave it like that first. Status property will switch to lost or won when the game has ended. This is again a persistent data structure. Updating the game state creates a new state and leaves the old one intact. This is again a persistent data structure. Updating the game state creates a new state and leaves the old one intact. Interesting. So we can't really change the state. We can only create a new one with different values and then start using it instead of the old one, potentially. Maybe that's my understanding of what that's saying. Actor object represents the current position and state of a given moving element in our game. All actors conform to the same interface. The position property holds the coordinates of the top left corner. Size property holds its size. And they have an update method which is used to compute their new state and position after a given time step. Simulates the thing the actor does, moving in response to the arrow keys for the player, bouncing back and forth for the lava, returns a new updated actor object. Type property contains a string that identifies the type of the actor, player, coin, or lava. It's useful for drawing the game in the look of the rectangle drawn. This is useful when drawing the game. The look of the rectangle drawn for an actor is based on its type. Actor classes have a static create method that's used by the level constructor. One back here. This creates an actor from a character in the level plan. It's given the coordinates of the character and the character itself, which is needed because the lava class handles several different characters. So lava, there's multiple behaviors for lava. It could be the dripping lava. It could be the side-to-side lava. It could be the, was there an up and down lava? I don't remember what the last one was. This is the vec class that we'll use for our two-dimensional values, such as position and size of values. So this is pretty much just an XY class. We have like vec2d is called in some languages and frameworks. Times. Why would we want times, I wonder? Times method scales a vector by a given number. It'll be useful when we need to multiply a speed factor. A speed vector by a time interval to get the distance traveled during that time. Okay. Take your word for it. Different types of actors get their own classes since their behavior is very different. Let's define these classes. Get to their update methods later. The player class has a property speed that stores its current speed to simulate momentum and gravity. Speed and position. Type is always going to be player. What is this get notation? I'm going to have to check into this. Does that mean you can do like player dot type as a property and it will call the function for you, kind of like properties in Python? Is that what that's like? Yeah, okay, wow, I had no idea JavaScript had this, actually. It's basically like making a property in Python. We give it a name, and technically it's a function. You know, it has parentheses, it accepts arguments, in this case there are none, but it has a function body, it has a return. You know, it is a function, but by putting this get here, it's making it so when you go to access it, you don't need to use the parentheses. You can access it as though it's just a value rather than a function. Which is interesting. I wonder if there's a way you can access the function itself, which are also objects in JavaScript. Because if you didn't have the get here, and you just did .type with no parentheses, it would return to you the function, not call it, and return to you the return value. This part is making it do that. I wonder if there's a way to get the function object or not. So create returns a new player at position -0.5. I think, right? Because this is going to get plus together, so it's going to be like 0 plus 0, and then -0.5 plus 0. Because a player is 1.5 squares high, its initial position is set to be half a square above the position where the at character appeared. This way its bottom aligns with the bottom of the square it appeared in. Size property is the same for all instances of player, so we'll store it on the prototype rather than the instances themselves. We could have used a getter like type, but that would create and return a new vec object every time the property is read. It would be wasteful. Strings being immutable don't have to be recreated every time they are evaluated. Sure, I follow what their immutability has to do with that, but okay. When constructing a lava actor, we need to initialize the object differently depending on the character it's based on. Dynamic Java moves along at its current speed until it hits an obstacle. At that point, if it has a reset property, it will jump back to its start position. Dripping does not have a reset property. It will invert its speed and continue in the other direction, bouncing. Create method looks at the character that the level constructor passes and creates the appropriate actor. I wonder if there's like... Say, I wonder if it has helper that would do this stuff for you, but... Okay, so all lava has the same type. Kind of interesting. Character. I almost want to use, I think I want to use character. Or symbol? Let's do character. CH feels a little bit too shorthand and ambiguous. I'm not really trying to save space. The author chooses particularly small function names and doesn't add a lot of extra new lines or anything like that to save vertical space while in horizontal space inside the book. Since there's a printed version of this book as well, they had to try to minimize the space that the code takes up, because more space means more pages means more money to manufacture the book, I assume. If it's an equal sign, has 2x and 0y. If it's a pipe character, and 0.2. This is kind of like where it's created in relation to the XY coordinate of the character within the map string. This is kind of essentially saying that this type of lava is going to get created two tiles to the right of where it found the equal sign. Is that right? This one's going to be 2 tiles down from where it found the pipe sign. And then the drippy one is 3 down from the current XY coordinate. Of a prototype size, it's always 1. It's basically the same thing we did on the player. Point actors are relatively simple. They mostly just sit in their place, but to liven the game up a little bit, they're given a wobble. I must say, if I was writing this chapter, I would have focused on the walls and the player first. I would have tried to get to the point where we can render the walls and the player and work on the movement, and then come back and add the lava, the coins afterwards. I feel like we've been coding for so long and we don't really have... We can't really run it yet. I mean, we can run it, but it's not going to do anything interesting. It would be nice to, if we had gotten knocked out a part where, you know, even if we just did rendering first, and didn't worry about the classes and the behavior yet. It'd just be nice to be able to see some progress at this point. Wobble. Wobble property tracks the phase of the bouncing motion. Together, these determine the coin's actual position, which is stored in the position property. Track a coin, the object stores its base position as well as a wobble property. Point 0.1. Seems odd. Point 2.1. How would we be starting at 2/10 and 1/10 of XY position? If I follow that at all. So my guess would be this is storing a angle in radians, because 2 pi in radians is equal to 360 degrees. So this is basically choosing a random angle between 0 and 2 pi in radians. Is between 0 and 360 degrees. Chapter 14, we saw that sine gives us the y-coordinate of a point on a circle. A coordinate goes back and forth in a smooth waveform as we move along the circle, which makes the sine function useful for modeling a wavy motion. Okay. Avoid a situation where all coins move up and down synchronously. The starting phase of each coin is randomized. The period of math sines wave, the width of the wave it produces is 2 pi. We multiply the value returned by math.random by that number to give a coin a random starting position on the wave. I guess we're not quite interested in the full circle, but the full one instance of the wave. I don't know. There's a term for that. I don't know what it is. Is it one phase? No, I don't know what it is. It might be phase. You now define the level. Yeah, see here we finally do get this. I do think like it would have been nice to have this before. Okay, so they've got empty, wall, and lava are the ones we did. They've also got at, which is player. Okay, this is why they didn't do this earlier, is because we're putting these classes we defined in there. Yeah, I don't know though. If it were me, I would have tried to get us to the point where we could run it and see something interesting a little bit earlier if possible. Gives us all the parts needed to create a level instance. I actually have this, right? By 9. Okay. Guess would be... Guess we can't put this above all of those things. It needs to be down below. Weird though, why would not hoisting bring it up? I guess maybe classes don't get hoisted? Task ahead is display such levels on the screen, model time and motion inside of them. Encapsulation as a burden. So we have our level object. We're still not quite doing anything with it. So the code in this chapter does not worry about encapsulation very much for 2 reasons. Encapsulation takes extra effort, it makes programs bigger, and requires additional concepts and interfaces to be introduced. There's only so much code you can throw at a reader before their eyes glaze. Man, I feel like we passed that point a little while ago. Made an effort to keep the program small. Various elements in the game are so closely tied together that if the behavior of one of them changed, it's unlikely that any of the others would be able to stay the same. Traces between the elements would end up encoding a lot of assumptions about the way the game works. It makes them a lot less effective. Whenever you change one part of the system, you still have to worry about the way it impacts the other parts because your interfaces wouldn't cover the new situation. Cutting points. And we will encapsulate, and that's the drawing subsystem. The reason for this is that we'll display the same game in a different way in the next chapter. Oh, okay. Nice. So we're going to reuse these objects in the next chapter and basically change the UI out. So we won't use a table with a grid, right? We'll use canvas in the next chapter. Nice. Encapsulation of the drawing code is done by defining a display object. It displays a given level and state. The display type we define in this chapter is called DOM display. It uses DOM elements to show the level. Using a style sheet to set the actual colors and other fixed properties of the elements will make up the game. It would also be possible to directly assign the element style property when we create them, but that would produce more verbose programs, and then we'd have style inside JavaScript, which wouldn't be great. Calling helper function provides a succinct way to create an element and give it some attributes and child nodes. I'm going to call this... I'm going to call this make element. I'm pretty sure ELT is short for element. But it doesn't, in my head, when I see ELT, I don't really think element. So I'd like it to be a little more descriptive. And it's creating the element, so we should have make. Okay. Gotta knock stuff off the table. So this takes a name, it takes attributes as a string, and then it takes 0 to many children. Create an element with the given name. Loop over the attributes. Attributes will be an object. Looping over that. We're setting each attribute on the element that we created. Putting attribute name and then the value. This will be an object of key value pairs. As a convention for myself, I like to use $signs at the front of variables that represent DOM elements. Kind of stealing a little bit from jQuery. I'm going to add those. That way, as I scan the code, it's clear to me that that thing is an element on the screen rather than just some other value inside the program. Loop over the children, add each one to the DOM element. There are also elements in the DOM, so we'll add the $sign there as well. Display is created by giving it a parent element to which it should append itself in a level object. So make a div, give it the class game, and call draw grid, which presumably is going to return some number of children. Actor layer is null. So this gets weird. I don't know. Can you do a $sign here? Yeah, I guess so. I mean, I would, if I were writing this, I probably wouldn't call this DOM. This is like game container, game div. Probably more specific name that might be better. Level's background grid, which never changes, is drawn once. Actors are redrawn every time the display is updated with a given state. The actor layer property will be used to track the element that holds the actors so they can be easily removed and replaced. Our coordinates and sizes are tracked in grid units, where a size or distance of 1 means 1 grid block. When setting pixel sizes, we'll have to scale these coordinates up. Everything in the game will be ridiculously small at 1 single pixel per square. The scale constant gives the number of pixels in a single unit. Picks up on the screen. Alright, make a table. Give it class background. Ugh. I'm guessing we will need arrow notation here because we're trying to access scale. And maybe type? Or no, type is getting passed in. Scale at least though, I think we'll need this to be arrow notation in order to access scale inside of here. So they foregoed the brackets, but I'll put them because I think it makes the code more explicit. Okay, and they didn't use brackets here, which is why I have a bracket here and they don't. This has got a lot going on here. Draw grid, calls make element, creates a table, gives it class background, gives it width times scale. Then for those child elements, goes level.rows.map. So we're going to generate a list based on all the things in rows. We're going to call this function for each one of them. What this function says is make an element tr. So we're getting past the row. We make the tr. It gets style height times scale. And then its children within the row is row.map. Again, looping over these, calling the function, returning the list created by the results. This one takes the type and calls make element, td, and then class type. First level is making TRs, and then this level is making the TDs inside of them. And all those are going inside the table. As mentioned, the background is drawn as a table element. This nicely corresponds with the structure, to the structure of the rows properties of the level. Row, the grid is turned into a table row. Strings in the grid are used as class names for the table cell TDs. Triple dot operator is used to pass arrays of child nodes to make element as separate arguments. Calling CSS makes the background look how we want. I'm hopeful we're going to be able to run it after this and see some output. And truthfully, either way, I'm probably heading out before too much longer. I'm definitely slowing down, and it's getting a lot more difficult to focus. I think it's definitely getting close to time to call it. Whoa. Stuff fell off my desk. Getting close to call it a night, basically. I'm hopeful though, fingers crossed. I'm hoping after we get a couple of these in, maybe we can run it and actually see the level. That'd be really cool. Some of these, such as table layout, border space, and padding, are used to suppress unwanted default behavior. We don't want the layout of the table to depend on the contents of the cells, and we don't want the space between the table cells or the padding inside them. Background rule sets the background color. CSS allows colors to be specified as words or RGB, or actually hex also. Yeah, this is just explaining RGB. So the blue component is the largest, the resulting color will be bluish. See in the lava one that the red component is the largest. We draw each actor by creating a DOM element for it and setting that element's position and size. Yeah, I don't know. Display. Okay. So DOM display will make a div, give it the class game, and then call draw grid and put all the children into it. Pinned it to parent. So if we go document.body, then level, was simple level. Will this actually show? Class constructor must be... Is not defined. And child argument 1 is not an object. So we try to create the display. Call make element. We call draw grid. We have all these empty arrays. You have all these undefined ones. So it's when it's making the table. For some reason, when it's making the table, it's having arrays of undefined. So I feel like we should have had these arrays here. Those should have been in this instead of undefined. Or it should have been a list of lists, right? We should have had list of 9 elements. Each element is a list of 22. So I feel like the outer one seemed to work fine, rows, because we did get 9 lists. So that bit seems okay. We do have our 9 lists of 22 types. So this row is the list of lists. Well, no, this row is actually just this list, the list of types. Then this one says type, make element, ed. Dang. I feel like we're so close. I don't really want to go into drawing actors. I guess maybe though this is because we don't have the draw actor stuff set up. I mean, it feels like something is... I feel like these are wrong. These feel like they shouldn't be undefined. I don't know. I think I'm going to call it for now. I was hoping to get it drawing on the screen, but it doesn't look like we're going to get there, and I don't think I'm up to troubleshooting this right now. It may just be the case that we don't have enough code to do it yet. I don't know for sure though. I'll have to keep working on it tomorrow. See, like all this stuff, I don't know, this is like way down the line. I feel like we should have been encouraged to run it before this. Like, we're coding so many things before we actually run it. Like, if I hadn't been running it as much as I had, imagine how many errors in my code there would be. Like, I ran it way more than they seem to let on in the book. And I had to fix errors in several different spots. Like, it would have been a nightmare to troubleshoot if we hadn't run it at all this entire time. I really wish they would have gotten us to a point where we could try it sooner. Try something, right? Like, we don't need to be able to play the entire game, but it would be nice if we could at least see some portion of the level get drawn or something, right? I mean, it looks like we have this part right. Type empty, 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 empty. Making TD, no children. Making TR. Making table. I don't know. Yeah, I can't really focus on this anymore. I gotta head out for now. So thanks everybody for watching. Hopefully this was interesting, even though we didn't make it to the point where we could actually run it and see anything. Again, this was all from this book, Eloquent JavaScript. So if somebody wants to work alongside me or get a look at what this project is or make it for themselves, you can access this for free at eloquentjavascript.net. And I was working on chapter 16, which is a platform game. So thanks for watching. Hope you found this interesting, and I will catch you next time. I hope you have a good night and a good week and all of that. So thanks.